Hi dear students, today we have come a new video of class 7. In the previous video we have discussed about speed and the types of motion, that is uniform and non-uniform motion. We have discussed about the average speed and we have done some numericals. In this part we will learn a new thing, that is mass and weight. If you ask me that mass and weight is the part of motion, to tell the truth, no, it is not a part of motion. But as it is given to your book, and to whenever we have discussed in motion that mass and weight, it is used several times. Okay, so that's why we will discuss mass and weight here. Okay, so let's see. Okay, see, mass and weight, these two terms are generally used for same purpose whenever we have used it. But here we just want to see whether these two things are same or there is some difference between them. If anyone asks you what is your weight, directly we have told my weight is 40 kg, 50 kg, 55 kg or 30 kg. But whenever we have told this thing that my weight is 50 kg, whether we are right, that things we will explore. Let's see. Okay, so first we have to define mass, though the definition we have learned earlier in class 6. But here we have to do it again. What is mass? The quantity of matter contained in a substance is known as its mass. The quantity of matter contained in a substance. If I want to explain it, assume this is a brick. Okay, so we all know it is made by clay and we then burn the clay and then we'll get the brick. So in that brick, some matters are there which is contained in it, right? And that matters or that combination of matter is known as its mass. Okay, whenever we are talking about mass, the thing we have to mention here, the mass of a body is fixed and it is not changed from place to place. Why I have written this thing? Now, as I have told about the mass of a substance, just like the brick, if I have taken the brick into any other place also, it will be brick. If I have taken here, assume it is West Bengal. If I have taken to Uttar Pradesh, then also it is brick. If I have taken it to America, then also it is brick. If I have taken it to Moon, to Jupiter, every place it will be brick. And the quantity of matter contained in it, that should be same. And for that reason, we can say that the mass of the body is fixed. It cannot be changed. Okay, and it is not varied from place to place. If you have taken one place to another place, so that will be brick. It will not be a rasgulla, so that you can eat it. So as it is brick, so it will not vary. The mass of the brick is also not varied. Okay. So next thing is come, how do we denote the mass? We denote the mass by small m or capital M, that we have seen earlier also. Okay, generally we denote mass by small m or capital M. Okay, now the question has come that okay, we have learned about mass, but how we have to measure it. That is a very important thing. How we have to measure it. So for measuring it, we need a unit. Okay. So for any physical quantity, we need a unit to measure. What is the unit of it? So if I am talking about the SI unit of mass that we all know, that is kilogram. That is the SI unit, and which is abbreviated by kg. If I am talking about the CGS unit, the CGS unit is gram, and which is abbreviated by small g. Clear? So these are the units of mass. If anyone asks you what is the relation between them, that is also known to us. 1 kg equals to 1000 gram. That is the unit. Now you might be asking, okay sir, we have got the unit, but not only unit is enough to measure a physical quantity. We need an instrument by which we can able to measure. So here we have to discuss that which instrument we gonna use to measure the mass. See, this one also discussed in class 6 when we are talking about instrument. So the first instrument, the name I have taken, that is beam balance. Nowadays also it is very much popular to measure the mass of a body. Okay, how it looks? Simply two arms, and with the two arms there are two plates are given. So in one plate I have just keep the substance, and another one we have given the weights. Okay, and when these two things will be balanced, we can say what is the substance kept in left hand side, its mass will be what are the weights I have given. Okay, it may be 1 kg, 2 kg, 500 gram, 200 gram, 250 gram. By that we can able to measure. Now problem is that beam balance, it is a instrument where we need to do some trial and error. Assume we have kept some weight here. So it is coming downward. So we have to change the weight. Okay, that we have done, that we have seen in the vegetable market, in the fish market, this thing is going on. Okay, so to get rid of this problem, nowadays, what type of instrument we have used? We have used digital balance or electronic balance. So that things we have seen everywhere. If we keep the substance on the machine, then digitally the mass is given to you. Okay, whether it is 5 gram or 5 kg, 2 gram or 200 gram, everything can be measured by digital balance. And here this trial and error system is not given. So if I am just trying to conclude the whole thing, that as we have told, my weight is 50 kg, that statement is not right. We can say my mass is 50 kg. So by kg, this unit, we just want to represent mass, not weight. And that's why whenever we have started, I have told now, in generally, mass and weight, these two terms are used for same purpose, but it is not correct. Okay, the story of mass is different. Now you might be asking, then what is the story of weight? Then see it. What is weight? Let's see. Weight. What is it? So to discuss before the weight, we have to discuss about a story that we all know. That the story of Sir Isaac Newton and the apple. So when the apple is fallen from the tree, it is coming towards the ground, and that is shown by Sir Newton, and a theory is given to us that is known as gravitation. What is it? Now by that, Sir Newton has told to us that all the substance over the earth that is attracted by the earth towards it by a force, and that is known as force of gravity. Now the question has come from you, sir, how do we can able to measure the force of gravity? How much force is applied on us? How much force is applied on you? How we have to measure it? So that confusion is cleared by this concept that is known as weight. What is weight? So we can write weight of a substance represents the amount of force acting on the substance by earth, that is force of gravity acting on it. Okay, so the amount of force acting on the substance, that is known as the weight of the body. Okay, so weight is, we can say weight is nothing but the force. Clear? So whenever we are talking about mass, it is amount of quantity contained in a substance, and here it is told the force is acting on a substance due to the earth. So these two things are not same. Okay, now coming to the next thing, how we can able to measure it. So for that we need a unit. So what are the units of weight? So first we have to discuss about the SI unit. The SI unit of weight is Newton. Okay, now you might be asking, sir, you have written Newton in small letter. Is it correct? Yes, I am correct, because here I just want to write the unit Newton, not the name of the great scientist Newton. If I just want to write down the name of the scientist, here we have to write capital. But if I want to mention Newton as a unit, so that case it should be smaller, and it is denoted by capital N. What is the CGS unit of it? So there is a CGS unit also of weight, and this unit is dyne. Okay, that is also written in small, and here no symbol is there. We have to written dyne only. Okay, no capital D or nothing. It is written dyne. So now you might be asking, sir, how we can able to define Newton? There must be a definition. So for your class, the definition will be changed in another class. But for your class, what will be the definition? The definition will be the force acting on a mass of 0.1 kg or 100 gram due to the force of gravity is known as 1 Newton force. So the force acting on a mass of 0.1 kg or 100 gram due to the force of gravity, that is known as 1 Newton force. So if you have a substance of 100 gram and if you just keep it on the surface of the earth, how much force is acting on it? that much force should be equal to 1 Newton. Okay, coming to the another thing, then what will be the dyne, the another unit? So it can be written as the force acting on a 0.001 gram substance due to the force of gravity, okay, is known as 1 dyne of force, or we can write 1 dyne of weight also. Okay, so here also we can write 1 Newton of force or 1 Newton of weight. Okay, so these are two definitions of two units where we have mentioned that how we can able to measure the weight of a body. Many things we have to discuss from weight. Okay, let's see it. Now the next question has come. Okay sir, you have discussed about weight, you have given the unit also, but one thing is coming to our mind, that if a mass is given to us, how we can able to measure the weight? That is a tough thing that is come to our mind, that how we can able to measure the weight if the mass is given. Okay, so let's write the question. How does the weight can be measured if the mass of a body is given? In this case, what we have to do, we have to find out that how much force is acting on unit mass by the earth. Now you will be asking, sir, how that thing also we can able to find out? That is experimentally done, and that value is given to you, that you have to remember. That is amount of force acting on unit mass can be experimentally measured. Okay, so now you will be asking that, sir, what will be the value? Then tell me. So if I tell that whenever we are talking about 1 kg mass, the weight is acting on it, we can write force on 1 kg mass will be equal to 10 Newton, or to be accurate, we can write it is 9.8 Newton. Okay, so force on 1 kg mass, it is 10 Newton or 9.8 Newton due to the attraction of earth. Now how does it is found? So it is experimentally measured, so you have to remember the value. Okay, so from here we can give a quantity that is known as G. Okay, the quantity named as G, that is basically known as force per unit mass. Okay, and here the value of G on earth, it is 10 Newton per kg. That means for 1 kg mass the weight is 10 Newton, or for 1 kg mass the force is 10 Newton or 9.8 Newton per kg. Now if you think, sir, which value we have to use, either 10 or 9.8? that value should be given in question. That what value you have to use here, that value should be supplied earlier. So by seeing it, you can able to choose. Okay. Now the question has come, if the mass is given to us, we can able to find the weight of the body. Just like, what will be the weight of 5 kg mass? Then you can write, sir, for 1 kg the weight is 10 Newton. For 5 kg it will be 5 into 10, that is 50 Newton. If I am asking what will be mass for 2.5 kg, that is also very easy. 2.5 into 10, that will be 25 Newton. If it is asked that you have to take for 1 kg mass, the weight will be 9.8, then you have to multiply it by 9.8. If it is not told, you can use 10, you can use 9.8, there is no problem, there is no restriction. Okay. If it is told what will be the weight, what will be the weight of m kg mass, so you can say, sir, that will be m into 10, that will be your weight. So W equals to m into 10, and as the 10 is generally taken, that can be written W equals to 10m. But if the value of G, see, the value of G we have told for the surface of Earth, but if I have taken to another planet, there the value of G may be changed. So better we have to write weight, which is denoted by W, is equals to m into G. That is the equation. M into 10, that is for Earth. But if you have gone to another planet, then the value of G might be changed. Okay, so that's why then the weight will be W equals to m into G. So it is the equation by which we can able to measure the weight of a body. Understood? Let's see. Okay. So we have discussed about the unit of the weight and how we can able to measure it. Now the instrument which is needed to measure the weight. For mass we have used beam balanced or digital meter. But for measuring weight we need an instrument which is known as spring balance. Okay, what is spring balance? See, spring balance is an instrument. It seems to be looking like this, that here is a hook and by which there is a cylindrical thing, or sometime it may be a rectangular thing, okay, and around which another hook is there. If we just hang a weight here, what will happen, you know? Inside it there is a spring. So if you keep a weight here, that will extend the string. Okay, so the length of the string, it is increased. So more weight, okay, if you kept, then more the length increased by spring. And with the spring, one hook is connected, one pointer is connected. As it is coming downward, okay, so here some values are written. Okay, so when it is coming and it is fixed with a certain value, we can say that that will be the weight of a substance. Simple thing. See, I have just come here with a spring. So this is a spring, it is there inside the pen, we all know. So if you hang a weight, what will happen? You see, the length of the spring is increased, right? More the weight, more the length is increased. Using this phenomena, we can use the spring balance. Okay, more the weighty substance we have kept here, more the increase of the length, and by which we can able to measure the weight of a substance. Okay, and how we have told that here is a pointer fixed with the spring. As it is extend, so the pointer is coming downward. So as the pointer is coming downward, then we can get the exact value of the weight. And by this instrument, one very interesting thing we have seen, whenever we are talking about the weight of a substance, we see the weight is acting vertically downward. Okay, and that we have seen earlier also from the story of Sir Newton, that the apple is fallen downward. Everything, if we just left from a height, that is coming downward. Why? Due to its weight. So we can write down the direction of weight is acting downward. Okay, so if anyone asks you that what will be the weight of mass 5 kg, then you will be telling, sir, it is very easy, that should be 5 into 10, that is 50 Newton, and it should act downward. So weight is such a physical quantity which is having a direction. Whenever we are talking about mass, so if I am talking about mass 5 kg, is it having any direction? That the mass of a substance is 2 kg in north direction, the mass of a substance is 5 kg in south direction. No, it is not. Mass is a physical quantity which doesn't have any sort of direction. But whenever we are talking about weight, the story is different. The weight is have a direction. The weight have a direction which is acting downward. Okay, vertically downward. That is the direction of weight. Okay, now we will go for another thing, that is gravitational unit of weight. You might be asking, sir, we have discussed about the CGS and SI unit. Apart from this also any unit is given. Yes, my dear, there is another unit, that is gravitational unit of weight. Let's see what is the gravitational unit of weight. To tell the definition of it, it is written when the mass of a substance is directly converted into weight is known as gravitational unit of weight. The mass of a substance is directly converted into weight. That means, assume a substance mass is 5 kg. So 5 kg is very much close to my heart. That's why I use that term several times. So if the mass is given 5 kg, so how much weight is given? So 5 kg mass gives a weight of 5 kg, along with we will add a small f, 5 kg f, and this small f stands for force. So force given by 5 kg mass, that is 5 kg force or 5 kilogram force. This unit, this kgf, I know there is a very interesting film by name this KGF. There is two chapters, chapter 1 and chapter 2. If I am not wrong, I think you know that very well than me. Okay, so KGF here It is a unit of weight which is known as gravitational unit, where we convert directly mass into weight. Now you might be thinking, sir, it is very easy. Yes. What will be the weight of 2.5 kg mass? So you will write down, sir, it is 2.5 kgf. What will be 1 kg mass? It will be 1 kgf. What will be 100 kg mass? It will be 100 kgf. Simple thing. What will be the mass that will be directly converted into weight by a unit, that is kgf? Clear? So that is a gravitational unit, and here it is not a SI unit, not a CGS unit. It is typically gravitational unit which is not belong to any unit system. Clear? Now coming to one thing, if I have taken for 1 kg mass, if I convert into weight in Newton, then you might be asking, sir, we all know that is W equals to m into g, where 1, that is the mass, and the value of g we have learned earlier, that is 10 Newton, and that will be 10 Newton. So 1 kg mass having a weight of 10 Newton, and 1 kg mass in gravitational unit, it should have 1 kgf. So we can write down a relation, that is 1 kgf equals to 10 Newton. Similarly, we can write 1 into 10, it can be written as 1 into 9.8, because we have taken the force on 1 kg mass due to earth, that may be 10, that may be 9.8. So 9.8 and 10 is very close. Okay, which is given to you in a numerical, that value you have to use. In that case, it will be 9.8 Newton. So 1 kgf, that should be either 10 Newton or 9.8 Newton. That is a unit which is known as gravitational unit. Okay, where the mass of a substance is directly converted into weight by just putting a F at the side, that is kgf. Okay, that is the whole story of weight. Now here we have to discuss some of the characteristics of weight, because the characteristics of mass we have discussed earlier. Now we have to discuss about characteristics of okay, that is weight. What are the characteristics of weight? Number one, weight of a substance can be varied from place to place. For the case of mass, we have told that mass of a substance cannot be varied from place to place, because it is the quantity of matter in a substance, and it should be remain same if you have taken to another place. But weight can be varied, just like we all know W equals to m into g, where g is mass, sorry, g is weight per unit mass. Now you see this weight per unit mass means 1 kg mass. Okay, so here unit means 1 kg we have taken. So the value of g, that should 10 or 9.8 in earth. Okay, but if I have taken to another place, assume we have taken to moon. So in moon, the value of g, that is written as g of moon, that will be 1 by 6th of g of earth. Means whatever the value of G on earth, it's 1 by 6. That means if I have taken the value, that is 1 by 6 into 10. So 2 3s are 2 5s are 5 by 3, and if I take it in a point, it will come near about 1.6. Okay, it will go 1.66 or etc. So 1.66 Newton per kg. So if I have taken a substance here to the moon, then its weight will be changed. In this surface, assume, again I have gone for that 5, a 5 kg mass, it is given to you. So in earth, what will be the weight? For earth, it will be WE, that is m into g of earth, that is 5 into 10, that is 50 Newton. But if I have taken to the moon, that is Wm, that is m into g of m, that is 5 into 1.6, then it will be 8 Newton. So clearly, as the value of G is different for different places, and that's why the weight of the substance, that is also changed if you have gone for different places. So it is clear that weight of a substance can be varied from place to place. It is not constant. Okay, and another characteristics that is also come from here, that if G equals to 0, then W equals to 0. Clearly that W equals to mg. If G is 0, then W will be 0. Then you might be asking, sir, is it possible that G can be 0? Yes. If you have gone to space, we know there is no gravitational force. In space, the gravitational force is 0. So as the gravitational force is 0, the value of G is also 0. Not only that, at center of earth, G equals to 0. If you have gone to the center of the earth, then also the value of G, the force, is 0 there. So there also the weight will be 0. We can write at space G equals to 0. Okay, and not only that, at artificial satellite. Okay, so in artificial satellite also the value of G will be 0. We have seen many videos now. The peoples, okay, those who have gone to the space, in the space station, they are moving here and there by just like seems to be swimming on the air, because there is no gravitational force. So simple thing, where there is no gravitational force, there the weight will be 0. Okay, so we can say that weight of the substance can be varied from place to place, as well as the weight of the substance can be 0. But if I am talking about mass, the mass of a substance cannot be 0, because it is a quantity of matter, so it will be remain same. Okay, so after that we will discuss some difference between mass and weight. Let's see. Okay, so talking about the differences between mass and weight, the difference is already given to your book, and we have also discussed whenever we are discussing separate characteristics of weight. So simple thing, if we have told about mass and weight, so the first definition difference will be the definition. Okay, what is mass? That is amount of matter in a substance, that is mass. What is weight? Force acting on a substance by earth. Okay, very common thing. Okay, number two, unit. The unit of mass is kg, and in this case, the unit of mass is a unit of weight is Newton. Number three, mass doesn't vary from place to place, where weight varies from place to place. Number four, mass of a substance cannot be zero. We all know that it is quantity of matter, so it cannot be zero. Every substance should have a quantity of matter. Okay, and if I'm talking about weight, weight can be zero if z equals to 0, that we have discussed in the previous part. Number 5, mass is measured by beam balance, where weight is measured by spring balance. So these are the common differences we have seen between mass and weight.